we go. Okay, welcome back. As I said, several of you have completed exercise 1 successfully. As far as I can tell, everybody who tried to do the exercise has everything set up as is expected. You had to change the listener on the server object, and you had to add a preload to the resolver object. And we're going to talk about how queries get into the resolver next. Before I do that, though, I thought I would just foreshadow a little bit one of the exercises that we'll do later. You may remember with authserve, we had commands that would allow us to access the database when authserve was not running. Turns out that there are similar database commands that you would see for CACHESERVE. So CACHESERVE, for example, dump configuration is a very useful one. And if I run that one, I have CACHESERVE running, I think, so I will use the CC driver, although CACHESERVE doesn't talk in terms of drivers. I think behind the scenes, it uses the same driver technology, but it's not exposed to the operator, so you can't see that. But here I do CACHESERVE dump conf. You can see that it complains because I haven't said which object I want to look at. So it's a little bit different than authserve. Authserve will just return the server object if you don't say which type of object you want to look at. So that means that we have to provide an object type. But better yet, we can provide a special keyword called all, and this has the very nice effect of returning all the objects. Unfortunately, there's nothing like this in authserve. People often ask me, how can I get a text representation of the whole configuration? So similar to a named.conf file where I have everything in one place and I can see the configuration. authserve doesn't offer that capability. Things are stored in various databases for efficiency purposes, but this CACHESERVE dump conf with the all modifier gives us a complete representation of all of the objects. So we'll talk about auth monitoring later. That's the query store for the authoritative traffic. I mentioned layer before. That's something. The query store is the regular monitoring object. You can see this is in an unconfigured state, so that means that the query store is not active. The monitoring is not active. We have a resolver called world. I have not created the preload in my sample server, so I don't have the preload that you would have in yours. And then we have the server object, which has one property that is not the default, and we can see it's a list of IP address patterns, the 10net, the local IPv6 addresses, and the loopback address. And we have the view and the view selector. So that's kind of a bonus that CACHESERVE has, which authserve does not, is a means to fetch the entirety of the configuration all with one text file. So that's kind of nice. Okay, the next thing we're going to talk about is the views, and views offer the same ability in CACHESERVE as they do in AuthServe. That is, it multiplexes the DNS namespace so that a single server can offer different responses for identical queries. Typically, it is the IP address of the source of the DNS request packet that is used to decide which set of DNS data to provide. And that there are other options that are possible. CACHESERVE has a much richer set of keys to use for that view selection than AuthServe does. The idea of the views is it turns out quite different in CACHESERVE compared to AuthServe, whereas AuthServe's view is identical really in concept to bind. In CACHESERVE, the idea is spread across three different objects. You've got the resolver object, which does the bulk of the work in CACHESERVE, and then you have a view and a view selector. So the purpose of this next bit of discussion is to describe the relationship between the resolver, the view, and the view selector. So we'll start with the view selector, and out of the box there is a single view selector. Let's go back to NOMTEL for just a moment. NOMTEL, CACHESERVE, and view selector get. So there is one view selector, and its properties consist of this one parameter of view equals world. The view selector is the filter. If you think about the views that we had in AuthServe, there was a match statement that allowed us to restrict which queries were permitted to request to receive content from the zones in that container that the view represented. In CACHESERVE, instead of having a match statement on the view, there is a separate view selector that points to a named view. So the view selector, I'd say it's a filter. So this view selector, I'm going to just say update for the purposes of using my tab completion to see what are the possible filters that I could use. And you can see here that this filter that the view selector implements for the system, this filter can have a lot of properties. It can be the destination address. In other words, the view selection or the filtering can be based on the destination IP address. That's the same as in AuthServe. You could match views based on which IP on a multi-homed server received the address. But we also have interface, so we can instead of the IP address, we can say if we get the query on this interface, then we'll send that query to a particular view. Source address is exactly the same as auth-serve, but here we also have source ports. So we can look at the port number on the DNS request, the inbound request from the client, and we can apply view selection based on that. So there are more options than maybe we saw in auth-serve for the view selection. But when we look at the default view selector, again, I'll just say view selector get, we don't see any filters at all. All we see is a pointer to the default, to the world view, which happens to be the default one, but a pointer to the world view. So this view selector that is built into the system, in fact, there's another weird thing that you see about this, and that is there could be many view selectors, and yet I fetched this default view selector with get. I didn't use mget. I could have. So mget shows me this default view selector as well as anything else, but there is nothing else. So this is odd. This default view selector is a little bit strange in that it's kind of magic, because I say it's magic for two reasons. The first reason I say it's magic is this behavior. I didn't have to be more precise about what I wanted to get. So in other words, I didn't have to select which of the view selectors that I wanted to get. And I could have identified it by the destination address, the source ports, the interface. So those different filters, I didn't even have to specify which filter that I was talking about. So that's the first way that it's magic. The second way that it's magic is that it accepts traffic from both IPv6 and IPv4. So if I go back to my picture here, this comment is going to make a little bit more sense, because I can create a view selector that has a source address here. And so this source address happens to be a block of IP addresses, which says this represents the filter for anything that comes from 192.0.2. All of those should be processed by this filter. And then here's another view selector, in other words, another filter that has a source address of this 2001 IPv6 address. So these are examples of two view selectors that I could create, and out of the box, though, there is only this one default view selector. It's unidentified or magic. I call it magic. I'll call this the magic view selector because it accepts all IP address. In other words, it's an open filter. All IP addresses from any source address, any source port, any interface, doesn't matter. It accepts everything, all address families. So this view selector, its job in life is to filter and then point that query, that inbound request, to a view. So the required parameter or property of a view selector, even for the magic view selector, which has no filter, but it does have a view. It points to a view, call it world. World happens to be the default. And that's the one that we see in our picture here. We get from the server is that we see there is this default view selector. So that's that one. points to the view called world. These other view selectors I could make have source addresses in IPv4 for, say, some customer. So I know customer X has this block of IP addresses. So that means this view is associated with this customer. And I happen to know that this customer also gets this block of IPv6 addresses. So I can associate this view with the individual set of IP address blocks in IPv6. So these are examples of selecting the filters, of the view selection as a filter. And this is a much more granular way of doing things than was possible with authserve. Authserve, you would typically have maybe 2-3 views at most, whereas with CACHESERVE, when we work with the SIA solutions, the secure internet access solutions called Secure Consumer, which implement this what is it called? The child protection services and the filtering, the web filtering, the controls, the parental controls. Those require views which are based on individual subscribers, individual customers. So there might be a view for every single customer in the entire network. So therefore, there could be hundreds of thousands or millions of views in the system. So it's quite a bit different than in the case of authserve. And that's why there is a completely different mechanism for view selection, just to accommodate the fact that there is the potential to have hundreds of thousands of views, which we couldn't do with the construction of authserve. And there are other reasons as well. The idea is here, and here's if we look at these view selectors that are pointing to these different views, the idea is here that the generic customer comes in and goes to the world view, whereas the specific customer X goes to a view that's dedicated to that customer. If we look at the view.mget, you can see that there is a default view called world, and it has a pointer to a resolver, which is also named world. And that's the one thing that a view must have besides a name. View selectors don't have names, they just have filters. Unless you're the magic view selector, the default view selector doesn't have any filter. It absorbs everything. But the views must have a name, and the other thing they must have is a resolver. So a view must have a name and a resolver. It must point to a resolver. So here's an example of customer X view, which points to a resolver called resolver for X. So these names of the views, the name of the resolver, these are completely arbitrary. Out of the box, there is the world resolver, which is so named because it operates with the natural DNS, which is visible to the entire world. That's where the name world came from for the default. So these views point to this resolver. So this the situation that we see. On the top line, we have the default situation, which is represented here in what we see with the view selector get points to the world view, and the view called world here points to the world resolver. So we have this sequence, view selector to view to resolver, and that's how the system was working for when you first turn it on. So this morning's lab was completely working with this path. Everything was absorbed through the view selector, which pointed it to the world view, which then went to the world resolver. And this is where all the action is. The DNS resolution takes place in here. This other guy here, customer X, all of his queries. How do I know they're his queries? Well, based on the IPv4 or the IPv6 address, they go to this view called customer X, which is pointing to a separate resolver, and hence this resolver called res for X will do something presumably different than what is in the world resolver. Ultimately, the reason that you have different resolvers, and typically there are only maybe 2 or 3 different resolvers, and sometimes only one resolver on a system. So a typical cache serve may have a couple resolvers at the most, 3, 4, maybe. I don't think I've ever seen more than 3, to be honest, but you could have more. There's typically very relatively few resolvers. What is a resolver? Well, if a view selector is a filter that points to a view, and the view is a sort of staging area that points to a resolver, what is a resolver? And down here on the bottom, this is what I want you to remember. A resolver is a cache, and the instructions for resolving anything that is not discovered in the cache. So that's what a resolver is, and I'll repeat this multiple times so that we get it through our heads that a resolver is a cache and all of the instructions for resolving things that are not in the cache. Out of the box, when you first start CACHESERVE, it has the resolver named world, which has a cache, empty initially, of course, and the instructions for resolving queries that are not found in the cache. So those instructions are, if you remember the yellow boxes, start at the root and follow the delegations until you get to a server that knows how to answer the query. Those are the built-in instructions that I'm talking about. Some of the things that you can modify would include a preload, because a preload puts a permanent entry in the cache. That's why when you made that preload statement in the first lab, when you wanted the word localhost, that domain name, you wanted that to resolve to the IPv4 loopback. That 127.0.0.1 is a permanent entry in the cache. So that was updated in the resolver object because that's where the cache is. So that resolver might have a preload, and yours does, except for Julio. I don't know if you fixed yours yet, but everybody else, you had the preload in the world resolver. I could create another resolver, and you will in the lab. You will create another resolver that doesn't have that preload. So it would resolve that, it would return different names for the same request. So localhost would get 127.0.0.1 if you come in through the default view, but if you come in through customer X, you get NX domain because there is no preload. So it's more complicated, certainly, than auth-serve, where there was just a view which was the container for the zones. So the zones were kind of sitting inside the view. The resolver is sort of like the equivalent of the zones because that's the content. That's the DNS resource records that are going to be presented to the client. All of that is sort of, in auth-serve, consists of these zones that are in this container that we call views. And in auth-serve, the view selector is also squeezed into the view as in the form of a match statement on the view. So in auth-serve, it's like all of this information is all stuffed into the view. And so the view has a lot of things in it. Whereas in CACHESERVE, it's all spread out to all these different pieces. And I've already given you a hint about why that is. It's because we're going to need to have very specific behavior that is customer independent. CACHESERVE is able to do that, whereas auth-serve is not. Let me go to the demo. Let me know if you have any questions. I'm looking in the chat to see if there are any questions, or just shout out, unmute yourself and shout out and see if you have a question. So my system, so let me get a server, server.get. So I have a server that is configured in a similar way to yours. Okay, I'm listening on these IP addresses on Ethernet 1 and the loopback address. So I will dig at 127.1 and I don't know, spooner.com. So I get, this is my domain, so this is some IP address here. So I get an answer, and that answer came from CACHESERVE following this top line here. So a request came in. I have only one view selector called the default view selector. These don't have names, so I shouldn't say it's called default because it's magic. It doesn't have a name. Goes through the world view, which points to the world resolver. The world resolver started at the top, found .com, found spooner.com, got the IP address, and sent it back to the client, which was DIG in that case. If I had other view selectors that were more specific than the wide open promiscuous magic view selector that absorbs everything, I could create those view selectors here and then point them either to the world resolver, or world view, or some other view. Presumably I'm pointing them to some other view. That's the whole reason that I have the view selector. So what happens if I had if I didn't have a view selector? Well, I can't remove the default view selector, not because it's magic, but because, well, let me see. No, I can't. I should be able to remove the view selector. I was going to say what I can't do is remove the world resolver because there is a view that points to it, so it's in use. But I can remove the view selector that's the magic one. So I'm going to go back in and do that so I can show you what happens. I'll go back to CACHESERVE. If I try to remove the resolver object, delete, name is equal to world, it's going to complain. Because remember this picture here. If I try to delete this thing, this is at the end of the chain. And so if I delete him, there's going to be a complaint because the view is pointing. You see in the yellow text here, the resolver called world is is here. If I delete that, then this view is disabled, and we don't allow that to happen. So I'm going to start on the other way. I'd like to delete this entire chain to see what happens if there is no view selection, no view, no resolver. So I'm going to start on the other end, and I am going to remove the magic view selector. So view selector, delete. Magic again, because I didn't even have to give anything that identified the view selector. There is just the one magic one, and now it's gone. So if I do that, then can anybody guess what will happen if I send a request to authServe? So I'm just going to repeat, sorry, to CACHESERVE. I'm going to repeat my request, and you might see there is no answer here. No answer. Look at the status here. Refused. So this, you think about what happened when authServe did not have movie.edu, we got refused back. And that was because authServe didn't know anything about movie.edu. Well, we kind of now have created the same situation here because we have no view selector. We removed the view selector, which means without the view selector here, which transports the query into the view, which then goes to the resolver, there is no information that allows CACHESERVE to answer the query. Without a view selector that applies to my request, there is no way to get an answer. Therefore, the response is refused. So in a way, what I'm doing by removing the view selector is I'm disabling the entire system because there's no way for any queries to get into the resolver, which is where all the answers are. All the answers are either in the cache or they are fetched from the internet via the resolving instructions. So I'm going to put the view selector back. View selector add. And this doesn't have a name, but it does have a view. This is what I must specify. So view equals world. Okay, so now if I go back out here, where's my exit command? And then let's do a dig again. Okay, and I get the answer. So I have status is no error. I have one answer, and this is my IP address. You may not have noticed, but this TTL is less than it was before. See what it was previously is 14,400 seconds. It is now 14,055 seconds. So 360 seconds later, 6 minutes later, the time to live has decreased. That's because this answer came from the cache. And CACHESERVE knows that it cannot present this data as fresh forever. So it modifies the original TTL, the original time to live was 14,400. When it talked to the name servers for Spooner.com, it got this fresh answer, but now the answer has been sitting in the cache for a while, and the time to live is becoming smaller and smaller. When eventually this goes to 0, this entry will be removed from the cache. It's actually a little bit more complicated than that, but we'll come back to that later. So that's not a problem because it just means that CACHESERVE would go and fetch the answer again from the Spooner.com name servers. which, by the way, it knows where those name servers are now because it had to do it once. And so it's going to remember for a while where those name servers for Spooner.com live. And it will be able to get this answer faster than it did the first time around. Okay, so we've got this chain of things that implements the view system, but also describes the pathway for a query processing through the server. So you might say, why do you need these views in here at all? I mean, I've described the off-serve view as sort of a collapsing of all three items into the one thing called the view. Well, why don't we just have a view selector that just goes right to a resolver? And the reason for that is that the view can have a policy on it. So the view can be specific to an individual customer. That's what we see, in the picture. We can have millions of view selectors. We could have millions of views. And each of these views may have policies attached to it. And the policy may say, don't go to this resolver, but instead do some other thing. Maybe return a synthesized answer, or return a NX domain, or something like that. So it can have a specific policy. So that's why these views are here, rather than collapsing the sort of view. Why take, you've got this intermediate stop here. You go view world and then resolver world. Well, I haven't gained anything by stopping in the middle here. And that is true for normal DNS. But when we start applying individual policies on specific IP address blocks, that's why we need the views. So we'll talk more about these policies later on. Right now, all we need to know is that that these policies could be applied on a view. Of course, some of these sort of resolution modifications could be done in the resolver as well. And we talked about a resolver that contains a preload. So that's another mode of changing the response, but that's done globally for hundreds of thousands of views. But this individual view is a place to modify the behavior on a customer by customer basis. So typically, these multiple customers would share the same resolver. As I said, we might have hundreds of thousands of views, but typically 1, 2, 3, small number of resolvers. Resolvers take up a lot of space, because they have the cache. So they take up some memory, and they take up a lot of CPU because they do a whole lot of work. These things are very lightweight, this view. In fact, we used to call them lightweight views, and then we dropped the lightweight and just said, well, we'll call it a view, and people will know not to confuse it with an auth-serve view because this is cache serve. But this is very lightweight, very small memory footprint. The view selector, the filter itself, also very small memory footprint. So you can have millions. Yes, it takes up a lot of memory, but it doesn't hurt the performance all that much. Now, as we saw before, if I remove the view selector and have some view and resolver that are unattached, they don't do anything. Well, in the sense that they don't do anything with traffic that the CACHESERVE process receives, because there's no way for that traffic from any of the interfaces to get in here. So it's not used, but you still, some customers might want to have a resolver like this just for doing troubleshooting, because as we'll see later, we can, as an administrator, I can use a nomtel command to tell CACHESERVE to use this resolver even if there is no view selector. That's a command called server.query, which allows us to emulate traffic that comes from the network, and I could use it for that. So there are situations where it's handy to have this thing around, even though it's not doing very much. It's there for troubleshooting and monitoring, that's all. Okay, so you probably won't add lots of views and resolvers and view selectors by hand, and it's not something that you do a lot of. But where you would, I guess, if you do start making chains of these, you just have to remember that before you add a view, you have to make sure that the resolver exists. Otherwise, the view creation will not succeed. So this is just the reverse problem to what I was showing you with the deleting the resolver. So I couldn't delete the resolver while there was still a view referring to it. So here's an example of adding a resolver. Again, I can add as many resolvers as I want. Usually there will just be a handful, a few, one, often just one. And it will do normal resolution because I didn't specify any special properties here. So it will start at the root servers, create a cache, and put answers in there. So that's a resolver. Now I could add a view that points to either the world resolver, or I could change that if I later say, oh, well, I don't want to point it to the world resolver. I'm going to point customer X to the resolver for X. So I can modify these things the same way that you would modify any object that we've seen with the Akamai software. Now I could add a view selector that points to this customer X view. Here I'm adding an IPv4 block, a /25, and now if I want to add more, I add, so say I want an IPv6 address, I have to add a second view selector. So I can't modify the view selector to make a list of addresses. Instead, there's just a separate view selector. And when this view selection happens, the view selector that is the closest match to the whatever property is being examined. So we're analyzing, say, the source IP address. If the source IP address of the packet, if it matches, the closest matching view selector is the one that wins. So every IP source address matches the default view selector, but an IP source address that is 192.0.2.1, that matches this view selector more closely, so that's the one that wins. Whichever one is the closest matching, that's the one that controls the destiny of that query. Now, what are the differences in resolver? So we showed in this one, we're making a resolver for X, a resolver called world. What kinds of differences you might have? We've already talked about one, the preload. the loopback for localhost, that is a difference that you might have in a resolver. More commonly, there would be bigger changes. There would be like a stub, which is a private delegation to an authoritative server that CacheServe would not discover otherwise. Or a forward, which is sending to another caching server. We will look at these tomorrow. It says here they're not part of the standard course, but we're going to be looking at that tomorrow, partly because we have an authoritative server that we can use for the stub. So that's one of the reasons that we will do that exercise. But that lab we'll do tomorrow. I think it's at the end of the course. So those are some things that you can do with resolvers. We'll come back to that. So now we've introduced these objects. You saw the server object in Lab 1. I've talked about views and view selectors and resolvers now in preparation for Lab 2. So I want you to remember the picture that we had before, and then I've tried to color code where these things sort of live. So the server object refers to the process as a whole, and with regard to this pathway through the server, it's this blue region here which controls the listen on statement. So whether the process, the CacheServe process, whether it gets the packet at all from the interface is determined by that listen on matching. So that's the server at work. Next step in terms of the inbound query processing is to go through view selection and then to view. So that happens here. Once you get to the resolver is this combination of the cache and the instructions for how to look up things that are not in the cache. So when we're going through this chain of objects, keep in mind where these things live. All right. Are there any questions about view selectors, which are the filters, views, which are the middleman that simply sends the query to the appropriate resolver? So let's look on the exercise number 2. Don't forget that in exercise 1, you probably shut down authserve, so make sure that it started, CacheServe. Make sure that you restart CacheServe so that you can use NOMTEL and check that you're getting responses. So make sure that you get, for example, localhost, google.com, Akamai, just check some arbitrary names, doesn't matter. Then you're going to create a new resolver. It's called internal, and it will have natural DNS resolution. Verify that the resolver is there, and then this resolver called internal doesn't do anything unless we direct traffic to it through the view and view selector process. So we'll create a view called internal that points to the internal resolver, and then we'll create a view selector which filters on traffic from the loopback address, the 127.0.0.1, and routes it to the internal view. So that internal view routes it then to the internal resolver. Then you can check that you get the right answer from your request to 127.1 for localhost. What is the right answer? Remember, this internal resolver is natural DNS. So the correct answer, the natural answer, should be NX domain. And this question asks you about that. It asks you whether the answer is the loopback or whether it's something else. So that's what I want you to think about there. Also, send your request maybe to another of the CacheServe instances, or even send a query to a different IP address for localhost and see what happens when you get that. I'll also start to send you some queries from my traffic generator, and you should be able to figure out, using the resolver.statistics command, you should be able to figure out which resolver is responding to the instructor's requests. And then I'm going to have you stop CacheServe and then do a command which should fail, but I want you to see that the nomtel prompt does not necessarily mean that CacheServe is running. That's the lesson that I want you to learn there. So let's take a few minutes to do exercise 2. I'll shut down the recording for just a while.